Assalamualaikum, my name is Muhammad Akademi Zamri. So I want to present about introduction in titration in food industry. Titration is a quantitative analyte technique used to determine the concentration of a substance in a solution by rating it with a standard solution of non-concentration in the food industry. Titration is widely applied for quality control and food analysis to measure components such as acidity, salt content, vitamin C, sugar and preservative. The process involves the gradual addition of a standard solution known as the titrant to the sample solution known as the analyte until the reaction reaches the endpoint, which is detected using an appropriate indicator or a pH meter. There are several types of titration used in food analysis, which is acid-based titration is commonly used to determine the acidity or alkalinity of food products such as fruit juice, dairy products and beverage. The second is redox titration is used to determine the concentration of reducing agent such as vitamin C in fruits and beverage. Complex stoichiometric titration typically using ETA, which is applied to measure the concentration of metal ion such as calcium and magnesium in milk and other food products. Precipitation titration is used to determine chloride or salt content in processed food. Titration is an essential technique in analytical chemistry because it provides accurate, precise and reliable quantitative measurement. In the food industry, it helps ensure product quality, consistency and compliance with food safety regulation. Titration is also used to monitor the nutritional value, detect adaptation, control manufacturing processes and verify the food product meet established quality standards. As a result, titration plays a crucial role in maintaining food safety and protecting consumer health.
Titration is important is because it helps manufacturers check the exact amount of acid or base in food product. This is how they make sure every product has the same taste and quality. For example, look at the vinegar. Since vinegar contains acetic acid, titration is used to measure its acidity. If the acidity is too high or too low, the quality of the product may not be consistent. During the analysis, the acetic acid in vinegar is react with sodium hydroxide or NaOH through the titration process. For this reaction, we can determine the acidity of the vinegar. This is important because the acidity affects the quality of the vinegar. It also helps manufacturers make sure the acidity shown on the label is accurate and that the product follows a food safety regulation. Orange juice contains vitamin C, which is also known as ascorbic acid. To measure the vitamin C content, a DCPIP solution is used in the titration. By doing this test, manufacturer can check whether the amount of vitamin C matches the value stated on the nutrition label. This is help ensure the information provided to consumer is accurate.
To understand how titration works, we need to understand the theory behind acid-base reactions. Acid-base titration is based on a neutralization reaction where an acid reacts with a base to produce salt and water. In our example, acetic acid in vinegar reacts with sodium hydroxide solution. The balanced chemical equation is CH3COOH plus NaOH producing CH3COONA and water. During the titration process, an indicator is added to help identify when the reaction is complete. One commonly used indicator is phenolphthalein. It is colorless in acidic solution and turns pink when the solution becomes slightly basic. This color change allows us to determine the endpoint of the titration. Two important terms in titration are the equivalence point and the endpoint. The equivalence point is the point where the number of moles of acid is exactly equal to the number of moles of base. At this stage, the neutralization reaction is chemically complete. The endpoint, on the other hand, is the point where the indicator changes color and can be observed experimentally. Although they are not exactly the same, a suitable indicator ensures that the endpoint occurs very close to the equivalence point. Once the endpoint is reached, we can use the titration formula, which is M1V1 equal to M2V2 to calculate the concentration of the unknown solution accurately.
Hello, my name is Muhammad Ilham bin Abdul Malik. Now I will explain the equipment and chemical used in this experiment. The equipment include 50 ml burette, 10 ml pipette, 250 ml conical flask, beaker and white tile. The burette is used to deliver the sodium hydroxide solution accurately, while the pipette is used to measure the vinegar sample. The chemical used are the vinegar sample, sodium hydroxide NaOH, and phenolphthalein indicator. Sodium hydroxide is the standard solution used for titration, while phenolphthalein help us identify the endpoint by changing from colorless to a faint pink color. Now I will explain the procedure. First, 10 ml of vinegar is diluted to 100 ml with distilled water. Then 20 ml of the diluted vinegar is transferred into a conical flask. Next, 2 or 3 phenolphthalein indicator are added. The burette is filled with standard sodium hydroxide solution. The vinegar is then titrated with sodium hydroxide until a faint pink color remains for about 30 seconds, which indicate the endpoint. The titration is repeated 3 times and the average titrate value is calculated. Finally, the percentage of acetic acid in the vinegar is determined. The balanced chemical equation is CH3 COOH plus NaOH from CH3 COONA plus H2O. This shows that acetic acid with sodium hydroxide to produce sodium acetate and water. In this slide, I will explain advantage of this method. First, it is simple and accurate, making it easy to perform in the laboratory. Second, it a low cost because only basic laboratory equipment and common chemical are needed. Third, the analysis is fast and the result can be obtained in a short time. Finally, this method is suitable for food quality control, especially for determining the acetic acid contained in vinegar to ensure it meets quality standard.
One important application of titration in food industry is vinegar analysis. Vinegar contains acetic acid or CH3COOH, which give it sour taste. Acid-based titration is used to determine the acidity of vinegar and ensure it meets quality standard. In this process, sodium hydroxide or NaOH is used as the titrant, while phenolphthalein serves as the indicator. The endpoint is reached when a faint pink color appears, indicating the acid has been neutralized. Titration also used to determine the concentration of vitamin C or ascorbic acid in food products. This method is commonly applied to fruit juice, and dietary supplement. During this analysis, vitamin C react with titrating agent such as iodine solution. The endpoint is identified by a color change, showing that all the vitamin C in the sample has reacted. This helps manufacturers monitor the nutritional quality of their products. In conclusion, titration is an important analytical method in the food industry. It is used to determine acidity level and nutrient content, helping to ensure product quality and consistency. Titration also supports food safety and compliance with industry regulation. Through application such as vinegar analysis and vitamin C determination, titration demonstrates its value in maintaining the quality of food products.